Today we are starting stoichiometry, which is my favorite unit in chemistry. So the word stoichiometry, the way to pronounce it, you can see phonetically, stoichiometry. Once you get used to it, you can start calling it. It'll be easy, it'll flow out really well when you say it, but if you want, you can just call it stoic too. A lot of people call it that. It's my favorite unit in chemistry. It was founded by Jeremias Richter, who was a German chemist, and who was of Greek origin. And the word came from stoichion, element, and metron, which means measure. So that's how they got stoichiometry. So if you can guess by the name, the stoichion and metron to get element and measure, and we're going to measure the different amounts of something used in reactions. Pretty much to see how much of something we will create, or how much of something we need to make how much we need at the end for our product. So similar to cooking, what you can do is you can look at the different ingredients list, and then you maybe need to start with 2 sticks of butter, 4 cups of flour, 3 tablespoons of sugar, plus maybe a bunch of other things if you're making good yummy cookies, and at the end you get, say, 2 dozen cookies. So the similar sort of thing here, we're going to look at what elements or what compounds I need to throw together, and how long I need to let them mix, or if I need to add heat, or what I need to do to get whatever I want created at the end, whatever compounds are being created for the end of my product. So stoichiometry, we're just looking at those measurements and seeing how they transfer over. So really what we're doing is stoichiometry is a branch of chemistry that deals with the quantities of substances that enter into and are produced by chemical reactions. It shows the quantitative relationship between reactants and products in a chemical reaction. So again, how much product is formed when you know a given set of reactants. There's also a bunch of other types of calculations we can do with it, but we don't get into that till a little bit later on. Coefficients, a couple terms you need to know. Coefficients, they're used to balance the chemical equations. So if you look at a chemical equation, you can see the coefficients are the big numbers in front. So we know that the subscripts are the little numbers following the element symbol. Coefficients will be big numbers in front of the compound. And that's telling you how many of each one you have. So this would be like if you were doing the cooking example again, I would have 2 cups of butter. So the 2 would be like my coefficient. That's how many cups of butter I have. So that's what I'm using to balance out my 4 cups of flour and my 3 tablespoons of sugar, or whatever I'm using. The BCE just stands for balanced chemical equation. The BCE illustrates that chemical reactions follow the law of conservation of mass, which states that mass is never created nor destroyed. When you start out with something, it can change to a different thing, but the total amount of mass that you have is not going to change or leave. The number and types of atoms on the reactant side needs to be equal to the number and types of atoms on the product side. So we might have H2 and oxygen, O2, on one side, H2 plus O2, but then we make water on the other side, H2O. We would have to balance out how many we need of each thing to find our least common multiple. To make sure that we have an equal number of hydrogens on the left on my reactant side, and the number of hydrogens on the right on my product side, as well as my number of oxygens on the left needs to match my number of oxygens on the right, my product side. The coefficients are molar ratios of the reactants and products, and we can use those ratios to convert from one substance to another in stoichiometry. So back to our example with H2 plus O2 gives me H2O. You would need 2 hydrogens then, 2 H2, but only 1 oxygen, 1 O2, because remember hydrogen and oxygen are diatomics, so they always come in groups of 2. So we can't just have H and O, we have H2 plus O2. We would need 2 H2s, so we put a big 2 in front of H2, plus 1 O2, so a big 1 in front of O2. And that would give us H2O. And when we count up how many we have, we would need 2 waters. So 2 H2Os is how many we would make to balance out our reaction. So we can use that then to calculate if we have a certain amount of hydrogen and a certain amount of oxygen, how much water could we make theoretically. Each problem when you're doing stoichiometry is going to be 3 steps. The first step is you need to make sure it's converted to moles, which after you've done molar conversions, you would just use your mole island chart and it would tell you exactly how to get there. So if you're in mass, you're going to need to use your molar mass to convert it to moles. If you're in volume, you're going to need your molar volume of 22.4 liters per mole to convert to moles. And if you're in particles, you're going to need Avogadro's number to convert it to moles. A lot of people think that stoichiometry is a lot simpler than the molar conversions, the two-step molar conversions we did before. If your problem is already in moles, then you don't have to do this step. Your next step, so we would be drawing train tracks to do these. Your next step would be the mole to mole ratio using your balanced chemical equation, your BCE. So you would look at your equation. I need 2 hydrogens plus 1 oxygen gives me 2 H2Os. You would use those molar ratios, those coefficients in the front, to help you figure out how many of each one you need to convert how many tablespoons of butter turns in plus how many cups of flour gives me how many cookies at the end. And then your last step would be convert it to the required unit. So this answer, the mole to mole ratio, would give you an answer in how many moles you have and how many moles you've created. Your third step, you can convert it if it asks you for how much volume you have, then you convert from moles to volumes, that last step. If it was asking for mass, you would use molar mass, convert it to grams. If it was asking for particles of some sort, you would use Avogadro's number, convert from moles to particles. So it's just like two-step molar conversions, but we're doing a mole to mole ratio step in the middle of it. So if we did an example, what is the mass of Al2O3? So that would be aluminum oxide. That can be made from 25 grams of aluminum. So just like in all the past ones, you still start with your given, which would be 25 grams of aluminum. The thing you need to do when you write these is you now need to label with the unit, 25 grams, and you have to put the formula behind it because each step, you're going to be switching formulas in the middle when you do your molar ratio. So each step, write your formula so you can make sure you have them in the right spots when you do your molar ratios. So I start with my given of 25 grams of aluminum. I have 25 grams of aluminum, that's my given to start. I need to convert that to moles, that's my first step. So 1 mole is equal to my molar mass of aluminum, because if I'm going from grams to moles, molar mass is my conversion. So 1 mole is equal to 26.98 grams of aluminum. Aluminum is just the element by itself, so I can find my 26.98 on the periodic table right there. I don't have to do any calculations to find that. Grams needs to be on the bottom so that my grams can cancel out, so I would have my 1 mole on the top. There's 26.98 grams per mole of aluminum. My next step is the new step. This is where I use my balanced equation from up here, which we will be giving to you until you learn how to balance equations on your own. So you don't have to worry about knowing how to balance them yet. You can look up above and see the balanced equation. 4 is my coefficient here, 3 is the coefficient here, and 2 is the coefficient here. That's what you would use for your molar ratio. So this is why it's important to label it with what element or compound it is, as well as the units behind them. Because here I have moles of aluminum, so I need moles of aluminum on the bottom here so that that can cancel out. So there are 4 moles of aluminum to make 2 moles of aluminum oxide. So I'm going to use 4 moles of aluminum on the bottom so that my moles can cancel out and my aluminum can cancel out. So my aluminum is now gone. That unit is canceled out. I have 4 moles of aluminum can make 2 moles of aluminum oxide, Al2O3. So I have 2 moles of Al2O3 on top. Again, make sure you set it up like this. Don't try to do shortcuts because you don't get credit unless you set it up correctly as it's supposed to be. Don't try to be like, oh, that's actually 1/2. Write 2 and 4 so we can see where it came from here, from your balanced chemical equation. So I have 2 moles of aluminum. My moles have canceled out. Grams canceled out. Aluminum's canceled out. Now I have moles of aluminum to aluminum oxide, Al2O3. My question wants to know what is the mass. So mass would be grams. So I need to convert it. My answer is in moles of aluminum oxide if I were to calculate this. I want to know grams, so I'm going to go for moles, convert it to grams. I use my molar mass. So I have 2 moles of aluminum Al2O3, aluminum oxide. I need to put moles on the bottom, so my molar mass is how many grams per 1 mole. So I have 1 mole of Al2O3 on the bottom here. I'm going to the top, I'm going to put my molar mass. So I would add up 2 aluminums plus 3 oxygens, gets me 101.96 grams for my molar mass of aluminum oxide. That's how many grams are in 1 mole of that. So that's converting my answer to the correct units. It wants mass, So I do this step from moles to mass to get mass using my molar mass. Once I do this at the end, you can do it by typing it in as fractions and multiplying each step, or you can multiply across the top and then divide by everything on the bottom. So I do 25 times 1 times 2 times 101.96 divided by 26.98 divided by 4 divided by 1. And then my answer at the end should be 47.23 grams of Al2O3. So again, you can't just write grams, you need to write the answer, the unit, label it with the element or compound that you're getting at the end as well. Whatever your question was asking you to find. My top right unit, grams aluminum oxide, should match my answer and what my question was asking me for, my mass of Al2O3. 10 things to know about stoichiometry. This is kind of redundant, so I'll just go through them fast. You have to show your units or you don't understand the process, and that means grams, moles, liters, particles, and the chemical formulas or the element symbols. You have to show those. You then convert your given into moles. If it's already in moles, you don't have to do that first step. You have to use the units to understand the process. So again, label the units to make sure you're doing it correctly. Don't skip steps. You don't get credit for if that's what motivates you. Make sure you do it correctly. Then you use the balanced chemical equation and look at the coefficients. Remember, those are the big numbers in front to tell you how many moles of each one you have, so you can use the molar ratio. Again, you have to have the units or you won't understand what's going on. Then you convert the answer to the required unit based on what your question was asking you to find. You can use your mole island map there. Again, you have to have the units to understand this process. And those units on this last step will include the grams, moles, liters, particles, something in there, and chemical formulas. And again, it's not really that hard once you get into it. It's actually quite fun. Stoichiometry is my favorite thing to do. You can use it in other parts of life, not even just chemistry. Once you know how to do the initial conversions, stoichiometry is a lot of fun. So I hope you guys will enjoy it. Here's your little introduction.